We're going to look at the decomposition of hydrogen iodide. We're told it's a second order reaction, and we have some concentration information and some time information. So you need to know the mathematical equation that relates concentration and time for a second order reaction, which is what I've put up at the bottom half of the screen. Now, what do we have and what do we want? The rate constant. Okay, we have that. As far as the units, it's molarity to the -1, seconds to the -1. That means take the reciprocal of them, which is how I've written it down below. We need, tell me again, time or temperature? Nah, that's time. So ignore the temperature in the problem. That's a distractor. Time is 2 hours. And we have the initial concentration, don't we? Yes, we do. And we're looking for the final concentration. In other words, the hydrogen ion concentration at time t. Now, remember the way the second order equation looks, the left side of it is the reciprocal of the hydrogen ion concentration. And that's not what we want. We want the concentration, not the reciprocal. Okay, well, one thing at a time. Let's get the reciprocal and then worry about how to fix it afterwards. Okay, so we'll take the rate constant out and put it up there. Notice how I've distributed the units so I can more easily see where they are. They're in the denominator. We need the time. And, we have a unit issue. We're asked in terms of hours, but the rate constant has units of seconds in it. So we do need to do a seconds to hour conversion. And now we'll multiply by the time. Do a quick unit check. All right. I know we have molarity in the denominator. We'll talk about that in just a bit. And we need to add the reciprocal of the initial concentration. Let's do some of the math here. Alright, so we get that part, 3.69 over molarity. And 1 over 0.250, well, that's 4 over molarity. Now the units may look weird right now, but two things on that. Number one, whenever you add things together that have units, they have to have the same unit. You can't add 14 blue sparrows plus 6 liters. That doesn't make any sense. And secondly, when you're adding something that has units in the denominator, you have to make sure that you've got the same units in the denominator too. It's like adding 1/2 plus 1/4. You have to do something to that before you can add it. But here we've got molarity in the denominator, so we can just do a straightforward add of that. Now we're not done, because the problem didn't say what are the reciprocal concentration, or what is the reciprocal concentration. Well, how do we get that out of there? Well, we just take the reciprocal of it. But what else do we have to do? Right. Whatever you do to the left side, got to do to the right side. So that allows us to get the concentration of hydrogen iodide at the end, time t, and then we just take 1 over 0.769 and 1 over molarity. Quick common sense check. Final concentration is 0.130 moles per liter. Initial concentration is greater, 0.250 moles per liter. It's decomposing, so the concentration should go down as time progresses. Good.